Every time you open an app, an invisible checkpoint runs in the background. It validates your identity before releasing the data you requested. Failing to secure this checkpoint has immediate consequences. Most unauthorized access and large-scale data leaks stem from vulnerabilities in how an API verifies these requests. As a developer, this creates a specific pressure. You have to secure your data, but choosing a method that is too complex for your needs can stall your project with difficult-to-maintain code. Every authentication method maps to 3 priorities: simplicity, scalability, and delegated security. We'll evaluate 3 contenders: API keys, JSON Web Tokens, and OAuth. Each occupies a distinct zone, and none satisfy all 3. These aren't interchangeable tools. To keep your system secure and performant, the authentication method must match the specific architecture of the application you are building. API keys are the most direct option. Think of them like a static VIP pass. Possession of the pass itself provides the necessary clearance to enter. The developer generates a randomized string of characters. When the client application sends this key, the server authorizes the data transfer. This low latency makes API keys efficient for internal microservices or fetching public data like weather. However, this simplicity lacks context. API keys lack built-in expiration dates or granular rules. If intercepted, a third party can impersonate the client and drain the server's resources until manually deactivated. Because there is no automated expiration, you must manually identify the breach, revoke the compromised key, and issue a new one across all your systems. API keys prioritize implementation speed. They are reliable within trusted server-to-server environments, but they lack the fine-grained control needed for public-facing user applications. JSON Web Tokens, or JWTs, work differently. If an API key is a pass you show at the door, a JWT is an event wristband. It carries your credentials with you, allowing you to move through different sections of an app without re-verifying your ID. A JWT has 3 parts: header, payload, and signature. The server signs it. When returned, the server instantly verifies it hasn't been altered. This removes a bottleneck. The server avoids querying a database for sessions. Verification is handled entirely by the token itself. This creates a stateless architecture, allowing web and mobile apps to handle thousands of concurrent users without placing a heavy load on back-end database resources. The trade-off is a lack of immediate control. Because the server isn't tracking active sessions in a database, it cannot easily invalidate a single token before its preset expiration time. Forcing a specific user to log out requires creating block lists to track invalidated tokens. This adds back the architectural complexity that choosing a stateless token was supposed to avoid. JWTs trade precise revocation control for high scalability. This makes them the standard choice for modern apps with large, independent user bases. OAuth is the framework behind Login with Google or Sign in with Apple. It acts as a trusted intermediary between your app and a major identity provider. It uses delegated access, which allows a user to grant your app permission to access their profile data without the user ever having to share their actual password with you. This flow is more involved. When logging in, your app redirects the user to the provider's external authorization server. After approval, this server sends a temporary authorization code back. Your app then swaps this temporary code for a final access token, securely fetching the user's data. This removes the liability of storing user passwords and simplifies the sign-up process for the user, which often leads to higher conversion rates. However, OAuth requires significant setup time and creates a permanent dependency on the external provider's uptime and API stability. While it requires the most engineering effort to implement, OAuth offloads the most significant security risks and builds immediate trust with the user. Choosing between these methods requires looking at the specific entity you need to verify for every request. Navigate the choice using this decision tree. The first question: are you authenticating a system or a human user? If it's a system, like an internal microservice, API keys are sufficient, providing speed with minimal overhead. If authenticating a human, does your application interact with external platforms? For social sign-ins, OAuth is required, but if managing your own user logins at scale, JWT is the more efficient path. This architectural logic ensures your security effort matches your actual risk profile, avoiding the heavy overhead of OAuth for simple tools while ensuring user data isn't exposed by using simple keys in the wrong context. In enterprise-scale environments, these boundaries often overlap. Many applications combine these methods to handle different parts of the stack. An application might use an OAuth flow to verify a user's identity through a third party, and then immediately issue its own JWT to manage that user's session internally. Selecting an authentication method requires identifying exactly who needs access to what data and implementing the most direct security protocol for that specific request.